What's up, Webster Groves? This is Hickson Middle School 8th grade science, electrical energy goal 7. So in this goal, students will be able to explain how energy can be conserved, transferred, or transformed within a circuit. So this is about conservation of energy. If you're meeting the goal, you're able to explain how energy is conserved, transferred, or transformed within a circuit. And going above the goal, you are able to do what is expected here, but also show how energy is conserved after it leaves a circuit. So, what is the law of conservation of energy? This is something you're going to need to know to understand this goal. The law of conservation of energy shows that energy cannot be created or destroyed. It can only change forms. So we take a look at this picture. Okay, so energy is going in as the rider travels up the hill. When he gets to the top of the hill, he has available energy. And as he moves down the hill, that is energy in motion. Okay, we'll talk about potential and kinetic energy here in a second. Taz. So Taz burns a lot of energy. He's always moving around crazy. You may know someone like that, but Taz is always burning energy, but he has that stored energy inside of him whenever he eats food or consumes calories. So the energy it does not come, it is not created, but it comes from somewhere. And so energy cannot be created, cannot be destroyed. That energy in motion then it moves to somewhere else. So it's not destroyed. It's always there. It never leaves. So potential versus kinetic. Okay, so potential energy is like your available energy. It is the available energy that you have. So we're going to write available right here. Maybe we're going to write it. Okay, so whether you are, whether it's a rock at the top of a mountain or a car that's ready to start, it's the available, it's the potential energy. Kinetic energy is the energy of movement. Okay, it is things in motion. Okay, so if you don't have stored energy, you have energy that is in motion, that is moving. Okay, so these two words, potential and kinetic energy, also are going to help us to understand the law of conservation of energy. So how does this relate to electricity? Okay, so potential energy is the available energy. So potential electric energy depends on the volts. Here we have a 9 volt and we have a 1.5 volt. So which one has more potential energy? The 9 volt does, okay, because there's more volts here. So volt is a unit of electric force. There's more potential force in this battery than in this battery. Okay, so this is something that's important to remember, that potential electric energy is measured in volts. Okay, the more volts a source has, the more potential electric energy that it has. Electric energy can be transferred. We learned this in Goal 1, so now we're going to be evaluated on our understanding of it. We have 3 ways. We have induction, transfer of electrons through open air. We have conduction, transfer of electrons through objects touching. And we have friction, transfer of electrons through movement back and forth. Okay? So match these up. Which one is which? Let's say we have A, B, C. Okay, pause the video. You can try that yourself. If you match them up, you should get induction as B, the lightning. Conduction as A, the circuit, because the wires are touching. And friction as C, as the balloon moves back and forth on the girl's hair. Okay. Electric energy can be transformed. So here we have 2 different ways to transfer. A different type of energy can transformed to electrical energy. Here we have kinetic energy, okay, the energy of movement. Those blades are moving, and that is getting transformed into electrical energy in this wind farm picture. In another picture, we have electrical energy that can be transformed into other types of energy. So we have the battery, okay, and that is being transformed into light energy, and those light bulbs are giving off a little heat, so we have some thermal or heat energy as well. Okay, so this is electric to other types of energy. In this picture, we have other types of energy to electric. So again, electricity is not being made, it's just being moved into another type of energy, or another type of energy being made into electrical energy. Okay, so you've seen this picture before of the steel wool, and let me move it along here. Oop, too far. Okay, so we have the steel wool and the 9-volt battery, right? So the question is, what happened to the electricity here when it came out? Where did it go? Well, the electricity turns into heat energy as it lights this steel wool on fire. So it's not that the electricity disappears, it just changes into another type of energy. Nice. So in this one down here, we have electricity being transformed. So we start with the water flow that goes into the big turbine, and this is how electricity can be generated with dams that are along rivers. So water flow goes into the turbine, it spins the turbine, and as that turbine generator shaft spins, it spins against magnets and creates a charge. So this is generating electricity. It's moving that kinetic energy of the water flow into electrical energy. So it came from kinetic energy is where it's coming from. Alright, so here are the last questions. We have a solar panel, a transformer, and we have an LED light. Okay, so when the solar rays hit this solar panel, that energy goes into the transformer and then lights the light bulb. So what kind of energy does this start as? What kind of energy is produced? Think about the light bulb and what that is doing. And is any energy lost in the process? Okay, these three questions we are going to talk about in class. So try to answer those on your own. Pause the video and just answer these three questions using this picture. Okay, for each of these three questions. Alright, that's it, that's all, and thank you for watching. Goodbye. Good.